So I called it sub C prime. This is the set of things which are fixed by elements.
Sorry, Zach?
Yeah.
Can I ask a silly question? Why was the size of t lambda to the u?
What?
You said the size of t is lambda to the
So it's the size of the full Galois group is lambda to the m or
The
something.
same as V naught.
Right.
T is the same.
Oh, okay.
So
okay, okay.
it
It's just
divides
some
lambda
u.
to the m, so it's some lambda to the u. Yeah. Okay. So, so the pain will be over soon, but suppose K prime is the fixed field of T prime sitting inside KL. Right, so the picture is that so K prime is some subfield. What do I know about K prime? Well, right, so I have, let me continue to draw what I have. I had beta sitting over P, beta prime sitting over beta. If I look at the intersection of beta prime with this subfield, beta double prime, fact 2 tells me about the ramification of this guy. Right, so fact 2 says if you take the fixed field of the inertia group, you know something about how primes ramify. Right, so if I start with KL, this compositum, take the fixed field corresponding to the inertia group, then that fact says over there that beta double prime is unramified over P. Okay, so it's nothing more than taking the inertia group, looking at the fixed field. It no longer ramifies. So I mean, the K, to give you a better perspective of what I'm doing, the K prime was the field that I was mentioning earlier. K prime is going to be a field, right? P does not ramify in K prime. Beta double prime is unramified over P. And no new primes ramify in K prime. Because if some new prime ramified in K prime, it would also have to ramify in KL as well. But I mean, right, L was a subfield of a cyclotomic field. Fact 5 says that P was the only prime that ramifies there. So no new primes ramified in K prime. And the convenience of this field K prime is that this prime that I wanted to sing no longer ramifies there. And what I'm going to show is in fact that KL, this compositum of KL, is actually equal to the compositum of K prime L. Okay, so why is this important? Well, right, K prime is a field for which I've removed the fact that P ramifies. So no new primes ramify. P is now unramified in K prime. If M is cyclotomic, well, I already know that L is cyclotomic because L was the subfield of a cyclotomic field. So this product is cyclotomic. So then this product would be cyclotomic as well. But K is a subfield of this guy. So K would have to be cyclotomic. So if I knew that this new K prime was cyclotomic, then I would get for free that K was cyclotomic as well, right? And the convenience here is that K prime has one fewer ramified primes. Okay, so let me quickly work that out. Okay. So okay, so why is this true? Well, first note. So I claim that if I actually look at the intersection of K prime with L, I'm going to get Q. And so let's see why we get that. Right, so look at this beta prime, sorry, which is this prime sitting inside K prime. And let me look at beta double prime intersected with L. So, right, on the one hand, this thing sits inside L, and L was a subfield of Q adjoins zeta P, where P totally ramifies. So, right, on the one hand, it's totally ramified. This intersection is totally ramified. Right, and the reason for that was because P was totally ramified in L. This is a prime which actually sits inside L and lies over P. B prime intersects unramified. Here says that intersection is actually, in fact, Q. That's the only time something could be totally ramified and unramified, is if the field is Q, if you're looking at it. Okay, well, so if the intersection of my two fields is Q, what can you tell me about the degree of their composite? It's just the product. Okay, at degree Q, so I know that the degree of L over Q is actually equal to lambda to the U. Right, but so lambda to the U, and let me just write down what I was going to say. So that's equal to the degree of KL, the composite over K prime, because K prime is a fixed field of something of size lambda to the U. So those degrees are equal over there. And so if I just write out this formula, so